Welcome to lesson number 8. Learning target for today is similar to the learning target for lesson number 7, which is just to combine transformations using A, B, H, and K. And we're going to be using these in order to transform certain parameters of our original function. So remember, A is your vertical stretch. If this value is negative, then it's also going to be a reflection in the x-axis. B is your horizontal stretch. If this is negative, then it's also a reflection in the y-axis. And then H, this is our horizontal translation, either left or right. K is our vertical translation, either up or down. Remember that if we are applying any of these parameters to a function, then the order in which we are going to do it is our stretches, followed by our reflections, and last, our translations. Right, so this is the order in which we want to apply any transformation of a function, unless otherwise told. Right, so if it tells you to do this one first, then just do that one first. But if it doesn't specifically tell you to do a different order, make sure you're following this order. All right, let's look at the first example. Class example number 1, we have the function y equals f of x. And then we are applying this transformation to y equals f of x. So if the equation is written in the form that we previously saw, a, b, h, and k, so this is a, this is b, this is h, and this is k, then we want to state the values of all of those. So a is going to be equal to 2, b is equal to 1/2, and h is equal to -5, and k is equal to -8. So what we want to now do is write the transformations associated with these parameters. So the way that we've changed our function by changing the parameters of a, b, h, and k. So the first thing we would have to do, number 1, is this a. So remember, the a value, if I bring it over here, this is a vertical stretch about the x-axis by a factor of 2. I'm just going to use initials here. Vertical stretch about x-axis by factor of 2. Next, number 2, I have a horizontal stretch. So horizontal stretch about the y-axis by a factor of 2. Next, I have a horizontal translation. So horizontal translation, and that's 5 units. If it's +5, that means it's going left. And my last transformation, I have a vertical translation, 8 units down. So if I were to sketch this graph for y equals f of x, if I were to apply these transformations, then this is already in the order of the transformations that I want to apply them in. All right, so this is my first transformation, this is my second transformation, and then these are my last transformations that I need to apply. So the next question, next example that actually same example is, the original graph was y equals x squared. And so what we want to do is write the equation that is going to result in applying these transformations. So my original equation is y equals x squared, and what I'm going to apply are my translations. So the first one was a vertical stretch about the x-axis, by a factor of 2. So what that's going to look like is y to 1/2 y. So that was the first thing I'm going to do. Secondly, we have a horizontal stretch about the y-axis by a factor of 2. So that we have x to 1/2 x. Then I have a horizontal stretch horizontal translation 5 units left. So this is x to x plus 5. And lastly, I have my vertical translation 8 units down, so that's y plus 8. Alright, so I'm going to apply all of these. You can do it one at a time, or you can do it all at once. This first one I'll do one at a time. So the first one I have is y to 1/2 y. So what that's going to look like is 1/2 y equals x squared. If I bring this 1/2 over to the other side, that's going to leave me with y equals 2x squared. Next, I want to apply this transformation. So I'm going to have y equals 2x squared, and that's going to bring me to y equals 1/2 x squared. If I simplify this expression, I'm going to start the next one, and well, if I square everything inside my brackets, that's going to give me 2 times 1/4 x squared. And if I bring that 2 in, so distribute my 2 into here, that's going to give me 1/2 x squared. So after applying that transformation, I have 1/2 x squared, which I'm starting my next transformation from. So y is equal to 1/2 x plus 5 squared. I just replaced x with x plus 5. And my last transformation is y plus 8 equals 1/2 x plus 5 squared, which is going to give me my final transformation. If I bring this 8 to the other side, I'll have y is equal to 1/2 x plus 5 squared minus 8. And that is the final transformation that I'll be working with. Now, the last question for this example is to graph this final equation in your graphing calculator. So that's something that you can easily do, and I'll leave that with you. All right, so let's look at another example. The next example we're going to look at is class example number 4. So the reason we're going to look at class example number 4 is because class example number 2 and 3, so number 2 is just graphing and moving about a graph, and class example number 3 is very similar to the one we just did, is very similar to class example number 1. So let's look at class example number 4. We have a function g of x, and g of x is equal to x cubed. And it's transformed into a new function, p of x. So g of x, we're going to transform into p of x. So to form the new function, p of x, g of x is stretched vertically about the x-axis by a factor of 0.25, or 1/4. All right, so that means y would go to 4y. We also know it's reflected in the y-axis. So if it's reflected in the y-axis, that means x is going to negative x. And it's translated 3 units to the right, so x goes to x minus 3. So write the equation of the new function p of x.